Thank you. So thank you everybody for coming to my invited talk yesterday. And this is just one small piece of work that I mentioned in my invited talk, but didn't get into any details. So the point is to do simultaneous translation with flexible or dynamic or kind of adaptive policy instead of the fixed latency policy that I mentioned. The first three authors who did all the work couldn't travel because of visa reasons. Unfortunately, I have to present this talk. So for those of you who attended my invited talk, so this is, I can probably skip this slide that it basically says that simultaneous translation has much lower additive latency instead of the multiplicative, like ×2 latency as in consecutive interpretation. So what I presented in my invited talk was mainly about this weight K policy, which is an instance of prefix to prefix framework. And another thing that is the average lagging metric for measuring latency. So basically, we train our simultaneous system with not using sequence to sequence, but actually using prefix to prefix because the source side is available to us piece by piece, so that we can only condition on the prefix. And by training it that way, we can basically enable anticipation. But anticipation has sometimes errors, so that's why we want to have this flexible policy to avoid anticipation errors. And this wait K policy, just to refresh your memory, is just wait for the first K source words and then one input, one output, one input, one output concurrently with the source sentence. And the AL, or average lagging latency, is basically measuring the degree of how much lagging behind you are from the source speech in terms of source words. Okay, as I said yesterday, that fixed policy might be too aggressive with smaller Ks. For example, in this case, weight 1 would make an anticipation mistake because the actual word, the noun is response, but it's only after 2 words that you can see this. So weight 1 is too aggressive, but weight 4 is too conservative on the other hand. So it is correct, but it's too slow. So what we want to do is something in between, but it kind of on the fly decide whether you should kind of catch up or whether you should wait for more. So you have consecutive writes here, 2 words in a row, and then wait for more information if you needed to, until you receive the word response, right? So this is more clever. So simultaneous MT model is our invention of the prefix to prefix framework. So what I presented yesterday is mostly weight K, and now we're talking about this block, which is adaptive and also simultaneous model. And this includes a paper presented on Monday from Google, which is a beautiful paper, and this work here, which I'm presenting now, which is not as beautiful. So previous work on adaptive policies, mainly from Gu et al., that I referenced a lot in my yesterday talk. So there are 2 actions, read and write. Read means wait for more input, and write means commit output words. So every time you have to decide whether you want to just wait or commit, right? So in Gu et al., they use reinforcement learning to learn this policy because there's no annotation of ideal read or write policy, right? So, but their work is rather complicated. Actually, as I said, we spent like 85% of our time trying to replicate this work, and our own work is very easy to very easy to do. They have 2 models. One is the base translation model, which is actually a full sentence model, and on top of that, a read-write model trained separately just to decide read or write. So they're 2 completely separate models. And the reason why this is very hard to replicate is mostly due to RL. Randomness in RL means the training is very unstable, and the performance is actually worse than weight K. So the question is, can we learn a better model and a simpler model for the adaptive policy? So our key idea is quite interesting. Is that a single model, actually policy as a model, by adding just 1 word or a read token to the target side vocabulary. So that target side vocabulary has 1 more word, so V plus 1. And then we just train this policy as a model or single model from scratch using prefix to prefix as before. But just except for the target words, I can also output a read token, in which case you would just wait for 1 more source words. So this is trained from scratch using prefix to prefix. So that's much cleaner architecture. It's a single model and it does it all, right? Except that the same old problem, there's no annotation of ideal policy, so you have to use either reinforcement learning or a kind of weaker version, which is called imitation learning. But the imitation learning is much easier than RL, but it requires that you have a dynamic oracle that is basically an everywhere defined optimal policy pi star, which tells you what's the best action to do anywhere in your trajectory. But that's too hard, because if you commit or output a word that is not in the reference translation, you are off trajectory, and we don't know how to recover from that. That's a very hard task. So nobody knows how to do that yet. So we just have a restricted dynamic oracle where if you want to write, you have to write the correct reference translation word at this current position. But if you want to read, you can also choose to read. That means you can always choose to go to the right to wait for more source words. But if you ever want to output any target word, you have to do it correctly. And then we have to, so this policy basically is from a pair of source and target prefixes to a set of actions. And a set of actions is basically in the set of vocabulary, a subset of the extended vocabulary, which includes the read token. So the expert policy of the restricted dynamic oracle is basically either you read or you output the correct target word. Only defined for those who have followed the correct policy so far, right? So if you have already deviated from the reference translation, we cannot recover it. So that's why it's restricted dynamic oracle or restricted imitation learning. But we also said you cannot be too conservative or too aggressive. So basically, there's two bounds, conservative bound and aggressive bound, and we hope you're in this middle region, which is good. But if you're ever in this region that is fall off the aggressive bound, you always should read. You should wait for more because you're being too aggressive. And if you're in the conservative region, you should always write. So this completes our modified definition of the restricted dynamic oracle or expert policy. But another problem is there are still exponentially many action sequences even within this little band with this expert policy. So we initially thought we should explore with this policy or explore with a model, which we usually do when we learn from dynamic oracles. But this is way too slow in training. So our hack, which is not very beautiful for this work, is just to follow these two conservative and aggressive bounds, these two kind of example policies, and then train the dynamic oracle just on these two policies. So that training is almost as fast as before, and you can redefine the loss function this way on these two bounds. And I have to say that the Google paper presented on Monday tries to summarize all the exponentially many paths, which is a more beautiful idea. We initially thought we actually wanted to do that direction as well when we first started, but it's just way too slow to train, and they probably have slightly better infrastructure for TPUs and stuff. But the idea is actually very beautiful in that paper. But our stuff is much easier. So this is experiments on Chinese to English and English to Chinese, and this is weight K, and this is RL from Gu et al. And in both cases, our flexible policy are slightly better than weight K in terms of latency quality trade-off. So that means if you have same latency, we have better BLEU score. If you have same BLEU score, we have shorter latency. And to give you two examples, so the first one is not willing to be named EU official, pointed out, blah, blah, blah. A weight 3 model being too aggressive actually would predict US official, because the training data for some reason has more US official than EU official, but that's too late to discover you have made a mistake. Our model actually decides to wait, rather, for 4 consecutive words on the source side, so then you get EU official, which is nice. But if you look at it more carefully, you will realize that you really made a mistake here, because you should say an EU, but that's too late. Because rather you should say one EU or US official. You can decide later. Because if you say then and after 2 seconds you have to say EU. But so that's unfortunate. And this example is the one that I presented initially that I've not received documents, which is wrong, and it should be I have not received response. And just to conclude, so we basically argue that adaptive policies are better than fixed latency policies such as weight K. And our contributions are mostly the single policy as model, which is a very clean framework just by extending the target side vocabulary with the additional read token into the vocabulary. So you can train a single model from scratch using the prefix framework. But because our training is slow, so we actually use a hack of restricted imitation learning with dynamic oracle and train on the two aggressive and conservative bounds, which is not ideal. So if you want to have any take-home message, this is the message. This is the picture that I want to have it as a take-home message. And I would like to thank you simultaneously. Okay, thank you.